Welcome to Developer Ramp-Up, a channel dedicated to anybody who wishes to become a software developer or a better software developer. In this video we'll continue talking about middleware in ASP.NET Core. So this is the second and the last video in a series in which we discuss this concept of middleware. If you didn't watch the first video, so middleware in ASP.NET Core Part 1, and you are really new to this concept of middleware in ASP.NET Core, then I strongly encourage you to pause this video and go and watch the first part so that you can get familiar with the concept of middleware. You can find a link to that video in the description or even somewhere here on the screen. However, if you are a little bit familiar with middleware, then you can also keep on watching this video because what we'll do now would be fairly understandable for you. Good. Now let's start with a short recap of what we did in the first video. And the recap will be really short. At the end we created two custom middlewares, and one was displaying hello from middleware 1 and the second one was displaying hello from middleware 2 in the browser. What we have seen is that if we delete this await.next, so if we forget it, or if we would simply, let's say, comment it out right now, what would happen is that the middleware pipeline would be short-circuited. And a request that comes into this middleware, when we perform this logic, it won't be sent to the next middleware in the pipeline. So a response will be generated and sent then back up the pipeline to the client that requested that specific resource. So this next delegate is very important because it simply passes the request to the next middleware in the pipeline. If we don't have it, then the request doesn't get any further. Now, we have used this app.use delegate or method in order to configure this custom logic. It's a very basic logic, but still custom logic on a specific request, or in this case on the response, because we write something on the response. However, if we want to use custom middleware, we have also other methods or delegates, and one of them is app.run. And I would like to start with app.run because it is fairly similar with app.use in the scenario where we forget to add this next delegate. So how can we use this middleware? It's very simple and similar to app.use. We'll use an async context here, and we would need a placeholder for the HTML context because we want to write something to the HTML context, and then we are ready to perform a certain action here. So await context.response.write async, and let's put here also some tags, the p tag, because we want to have everything displayed on different lines, and here we add hello from run. Let's make it like this, hello from run middleware. And that's basically it. We added a third middleware, a third custom middleware to the current middleware pipeline. So if we run this application right now, let's see exactly what happens, because we have three custom middleware that write something as response, and let's see what we will get on the browser. In a few seconds we should have the response. We have hello from middleware 1 and hello from run middleware. So what we notice is that we don't get this hello from middleware 2, which is here. And the reason why this happens is that app.run in a certain way is similar as behavior to app.use when we forget to add the next delegate. App.run is considered to be a termination middleware. So if you want to use it, you would normally use it at the end of the pipeline. So after this app.run shouldn't be any other middleware there. Because what it would happen when the request will hit this middleware, a response will be generated and sent back to the client. So what happens with our request is that it comes in, as we said in the previous video, from above. It hits this use developer exception page, then it's sent to the next middleware, and hello from middleware 1 is written to the response. Then it is sent further, because we have the next delegate, to app.run, but app.run is a termination middleware, so we will write this here to the response context, and then the response will be sent. So this third middleware that we have configured will not be hit by the current request. And let's prove that this is true. Let's simply cut this custom middleware from here, and let's add it here after our second custom middleware. So now we have only the use MVC middleware that wouldn't be hit, but since we really don't want to do any MVC here, we just want to show how middleware work, we can then put it here. And right now, if we run this program once again, the outcome should be slightly different. And what I would expect is to have hello middleware 1, hello middleware 2, and hello from run middleware. And in fact, that's really what the case is. So we have hello from middleware 1, hello from middleware 2, and finally hello from run middleware. So in this case, we see that all our custom middleware is working properly, and the app.run, which is always a terminating middleware, also does its job, and it writes something to the response, and in the end we will have all this information written to the response. So that is how app.run works. The important thing to note here is that this app.run is always a termination middleware, and if you need to use it, please use it as the last middleware in your middleware pipeline, or use it in scenarios where, for instance, in certain conditions, it is not important that the request should go further down the middleware pipeline. Good, so that's it from app.run. But now we have another very interesting method or delegate on the iApplication Builder instance that we have here, which is app, and it is called map. And that's fairly cool, so let's look a little bit deeper into what this app.Map means and how could it be useful. And let's start by looking into the definition of this map method. So if we press F12, we would get here on Microsoft ASP.NET Core Builder namespace, and then we have map extensions. So this map is an extension method in this case, and we can see that it takes this iApplication Builder app, which is typical for an extension method, and this would be provided by ASP.NET Core. So what we would have to provide is a path string. So this would indicate the path on which we want to perform some actions, and we need to also provide an action of type iApplication Builder. So let's go back and try to do that. First of all, let's add the path string, which would be Angular, let's say, because there is some cool stuff about Angular these days. And then we have to provide this action, and let's call this action and use a lambda. Okay, so till here everything is okay. Now we can call action.run. And here I just want to show you a really interesting thing. As I said, this action, as we saw in the definition, is of type iApplication Builder. So it means that it's the same type as this app. And this means in turn that we can use action and call each of the extension methods that we can call on app. Like for example, we used use or we used run. So in this case, we can call action.run, which would be exactly the same extension method as app.run. So it would take the exact same steps and the behavior would be identical. So in app.run, in this case, let's take async, then let's take the HttpContext and use another lambda, and let's here also await context.response. Sorry, let's go one step back. response.write async, and let's write here also something. Since this is about Angular, we will make it about Angular, but first of all, let's add these p tags. Okay, and let's say here Angular 6 was released on May 3rd, 2018, which is true. You can check it out, all the new features that are there for you in Angular 6. Good. So now we are ready with this app.Map middleware. Let's, however, change here this app.run because we haven't deleted it, and let's call it non-map, middleware. And let's run the software and analyze the outputs that we will see in the browser window. Let's give it a little bit of time so that everything loads, and we will see then what we have on the screen. So we have hello from middleware 1, which is okay because we used that app.use and also provided the next delegate, so it will pass to the next one. So that's why we have hello from middleware 2. But then we have hello from non-map middleware, which is the last middleware that we have configured right now in the pipeline. And this happens, of course, because this was a GET request to localhost 58004, so it didn't contain Angular, so this means in turn that app.Map middleware was not hit. So let's put in Angular. And you see that if we put here Angular, we get hello from middleware 1, from middleware 2, which is expected, and then we get Angular 6 was released on May 3rd, and of course, since we used app.run, the last app.run is not executed, so this one that we have here, and then we don't have this message displayed. So this is as expected. Good. Let's, however, try to do a different thing, because we can use this app.map to perform a real branching of the request. So if an incoming request has this Angular path, then we can configure an entire branch for it. And this means that we can configure an entire middleware pipeline just for this Angular path. And this would be fairly easy to do, because what we could do here is simply add or change something. Let's change this into an app.use. Here we have to provide a context and the next delegate. Okay, and here let's await next. That's fairly cool. And now what we can do is, however, we can go and do something else. So let's, for instance, display here only Angular 6. So let's take all this text out of here. And let's then here use another middleware. So it would be action.use. Let's also add the semicolon, and we make this async. We need to provide the context and the next delegate, and then use a simple lambda expression again. And here, let's just copy this from here. As also stated in other developer ramp-up videos, it's not okay to copy-paste code most of the times, but for demo purposes and not to waste time writing a lot of text, we copy and paste code that can be reused here. And Angular 6, let's say here, was released, and let's copy this entire, or no, let's don't copy it, because right now we will change it a little bit. And let's add here action.run, and here we need an async context and the lambda. Okay, semicolon at the end, of course. And here let's await context.response.write async. Let's add the semicolon first so that we don't forget, and let's add the p tag again. So that's done. So we have Angular 6 was released, and here on May 3rd, 2018. And that's fairly cool, and you will see it right now. Let's run it and see exactly what happens and analyze the response once again. So when we make the call to localhost, so to the content root, let's say, we get, of course, hello from middleware 1, hello from middleware 2, and from non-map middleware, because since we did not use Angular, then of course we did not hit the app.Map middleware. But then if we hit Angular here, you can see that the entire middleware pipeline under app.Map was executed, and we have Angular 6 was released on May 3rd, 2015. So this is how app.Map works. You can use it to really branch requests based on a path, and then take that request through a totally different middleware pipeline than all the other requests. And just as a simple example, this might be useful, for instance, if you have in your project also something like a landing page. And then maybe when requests for that landing page come in, you maybe want to do some additional logging, maybe you want to log some analytics and so on. So in those cases, it might be useful to use this app.map to branch the entire request to a totally different middleware pipeline. And in that case, all other requests would use the normal, let's call it default middleware pipeline, while the request for your landing page, which would be under this path Angular, would run then through a totally different middleware pipeline, from this point on at least. Good, but besides this app.map, we also have a app.MapWhen. And let's take a look into how app.MapWhen works. So let's make a little bit of space here and use app.MapWhen and parentheses and semicolon. Of course, once again, first we have this squiggly line because we have to configure some things here. And let's start once again by looking into the definition. And this is very similar to what we have seen in app.map. This is an extension method. It takes the iApplicationBuilder instance, and then what we have to provide here is not a path string, but a function, a so-called func that will take in an HTTP context, so the current HTTP context, and return a bool, so a true or false, which we'll call predicate. And then once again we need to provide an action. So let's try to implement this here into this app.MapWhen. The first thing that we needed to provide was that func that took in an HTTP context and returned a bool. So we have here context dot request, and let's, for instance, in this case, make an app.MapWhen middleware that would look at the query strings. And if it finds in the query strings of a request URL a key which is called name, then we'll use it to perform some actions. So we would have on the context request, we have the query, and here we have the contains key method. Let's use it, and then we have, of course, to provide the key, and the key should be name. So if we have this context request query contains key, then what we have to do is provide the action, and we will do this exactly the same way we did also in map, in app.map. So we'll call the action, we'll define the action and use another lambda expression here. And what we could do here is, first of all, var name equals, and once again context. Okay, something went wrong. So context. Oh, of course, I forgot here that we have first in this lambda, of course, we have action dot run. And let's put a semicolon here. and an async, and this will take in a context, and then another lambda expression, and that would do it. Now we have the context. So we can here write var name equals context dot request dot query, and here we can simply search for the key, which should be name. So now we have this variable name, and now we can await context dot response dot write async like we did previously. Let's also add here a semicolon and the p tags that we used throughout all these two videos. And here we could write hello, and let's use string interpolation here. So it would be like this, hello, and then here name. So it would take in our variable that we have defined previously. So that should do it. Let's run the application and see if everything adds up and if the outputs are expected. So once again, the first request is a GET request for the base URL. So we won't hit any of this map or MapWhen middlewares. But if here, for instance, let's add a query string, which would be name. Sorry, we have to add question mark. Name equals Dan. And let's see what's happened. And you see we have hello Dan here, which is kind of cool. So in this case, what happened is that we used that query string, and when the request started to go through this middleware pipeline, it hit this app.MapWhen, and this condition was true. So then we executed the action, which is an action.run, and there we wrote something to the response. Now I won't dwell any further on this, but the main idea is that you can use both the app.Map that we have used here and the app.MapWhen methods to branch requests. Because also here we could define an entire middleware pipeline that would be branched from the, let's say, parent pipeline, and the request would go through all the middleware that we could configure here. So it's exactly the same as it works also in app.Map. Then the question would be, of course, when to use app.Map and when to use app.MapWhen. And the answer here is fairly simple. We have seen that app.Map, we can do branching only based on the incoming path. While when we use app.MapWhen, we can do branching based on any condition that we could infer in a certain way from the HTTP context. And if we take a look at the HTTP context, we would see that we have really a lot of information available. And we could do here or apply logic based on headers, based on if it is HTTPS, based on payload. So really based on any property that is there on the HTTP context, and from which we could return a true and a false, we can apply some custom logic. So once again, in app.map, everything is very simple, but we can do this branching only based on the incoming request path. While when we use app.MapWhen, we can do branching based on any property that we find on the HTTP context, which is fairly powerful, I would say. So that's pretty much it on middleware in ASP.NET Core. In part 1 and part 2, we covered the fundamental topics on what a middleware is, how it is supposed to work, how we can configure a middleware pipeline in ASP.NET Core, and so on. And we also have configured our own very small custom middleware where we have applied some custom logic. In this case, it was very simple, just writing something to the response. But we saw that if we use app.use and we forget to add the next delegate, then this will short circuit the entire middleware pipeline. Then we have checked app.run, and we saw that this is a termination middleware, so nothing that comes afterwards, or none of the middleware that come afterwards will be executed. And then we we took a look into this app.Map and into this app.MapWhen methods, which allow us to branch requests and put them through a totally different pipeline based on a request path or on any property that we can find in the HTTP context. If you find this content useful, please subscribe to Developer Ramp Up. Feel free to share this content with your friends and your network. And should you have any feedback or question, just hit me with a comment. Also, don't forget to thumbs up. Thank you very much for watching, and until the next time, I wish you the very best.